Mathematical induction. Now usually we can't use inductions to solve or to prove anything in maths. Remember, induction is when we use values to prove that a statement or a theory is true. For example, we can't say that if the sine square, if they say prove that sine square x plus cos square x equals 1, we can't say, well, if x equals 60, then sine x is a half, cos x equals square root 3 over 2, therefore the sine square of x plus cos square of x equals 0.25 plus 0.75, so that equals 1. That is not a proof, because you can't just substitute values and then say, well, let's see what's happened with 61. Doesn't matter how many values we put in there, it does not prove that this is true. However, we have a process that under certain circumstances can be used to prove these things, and this is mathematical induction. So the mathematical induction, the principle of mathematical induction, can be used to prove a proposition under certain circumstances, such as, so let's say they give us a proposition that looked like this. I'll quickly talk about what proposition actually means. So if they give us the proposition Pn of n to 1 r equals n over 2 n plus 1. Proposition, not a preposition, a proposition. A proposition means that's a belief. So what we say is, we believe that the sum of this sequence from n to 1 is the same as this. And that's what the proposition is. I believe that that's true. Now I'm going to use mathematical induction to do that. Now let's quickly first look at how that will be set out. So let's say for the value, let's see if this is true when p equals 5. So if I have p, or n is 5, so if the proposition is 5, what I'm going to do is I'm going to substitute that p value, that n, into everywhere where I see an n. In other words, I will see that 5, the sum from 5 to 1r equals 5 over 2, 5 plus 1. Okay, so I've substituted that 5 into everywhere where I saw that. I'm going to break it up a little bit different than some textbooks. I'm going to work with the left-hand side and the right-hand side. I'm going to call this my left-hand side, and in my left-hand side, I'm going to calculate what this is. Now, remember, my left-hand side equals, and if I have the sum of r, it means it is from 1 to 5. So it's 1. If I substitute 1, if I substitute 2 there, it's 2 plus 3 plus 4 plus 5. And that equals a total of 15. What happens with my right-hand side? My right-hand side equals 5 over 2 multiplied by 5 plus 1 is 6. 5 times 6 is 30. 30 divided by 2 is 15. So this proposition is true for 5 because the left-hand side equals the right-hand side. Now that you know what the proposition means, we said, just like we said in this case, you can't just chuck in any values. The mathematical induction state that a proposition is only true under the following circumstances. First of all, we're going to look at the proposition must be true when p equals 1, or when n is 1. So when the probability is 1, not the probability, when n is 1, this proposition must be true. That's our first step. Once that happens, we're going to go at 2, and we're going to look at it exists if it's true under k, and it needs to exist at the next value, which means p at k plus 1. So we can almost see it as climbing a ladder. The first one is, yes, it exists when I get onto the ladder. One means I can get onto the ladder. PK means I can go to any rung of that ladder, and K plus 1 is true for the one next to it, and therefore it's true for any value. So that's the whole principle. And we're going to look at the examples to figure this out. How are we going to do this? It's also very important to note that this will only be true, this mathematical induction will only be true when for propositions that relates to natural numbers. So we can only work it with natural numbers. Look at the example before you stress out because it's a bit weird.